Here we are, starting with section 6.3, using the fundamental theorem of calculus to find definite integrals. All right, so first, let's go ahead and recall that the fundamental theorem of calculus says that the integral, the definite integral, from a up to b of the derivative of a function, lowercase f of x dx, is equal to the original function, or the antiderivative, as we could call it now, of b minus the antiderivative of a. All right, so we're going to go ahead and use this in example 1 to calculate the following integrals. So, how we're going to handle this is we actually need to go through and calculate these integrals using the antiderivative rules that we learned in our last section. All right, and then we're going to evaluate our integral that we find at the given points. All right, so the first thing we want to do is just ignore the fact that there is bounds on the integral. Let's go ahead and say make indefinite. All right, so let's observe the indefinite integral of 8x plus 1 dx. All right, from our rules, we learned that we could break this up into two different integrals. We have 8x dx plus 1 dx. We also learned that we could pull a constant out, so we have 8 times the integral of x with respect to x plus the integral of 1 with respect to x. And then we'll use a power rule for our first integral, so we have 8 times x squared over 2 plus, and our constant rule says that this is 1 times our variable, so 1 times x, which is x. And then we're going to need our plus c. Okay, so this ends up being 4x squared plus x plus c. So this is our general antiderivative. Okay, but we were given a definite integral. We were given from 0 up to 5. So what we need to do is evaluate our general antiderivative at 0 and at 5. All right, so I need some more space. 0 to 5 of this 8x plus 1 dx. All right, this is going to be our function 4x squared plus x evaluated at, so we use, I'm going to put these in parentheses, and then we use a vertical bar to mean evaluated at 0 up to 5. Okay? So we found the antiderivative and we need to evaluate it at the endpoints. I'm not including c, and I will show you why I'm not in a moment. Okay? So the first thing we want to do is evaluate at 5. So we have 4 times 5 squared plus 5 minus 4 times 0 squared plus 0. And I'm putting those in brackets because that minus has to apply to the whole thing. All right, so in terms that we recognize, if this is lowercase f of x here, then this is uppercase f of 5 minus uppercase f of 0. This is just using our fundamental theorem, okay? So let's go ahead and evaluate. So 5 squared is 25, times 4 is 100, so we have 105, and everything on the right-hand side evaluates to be 0, so we end up with 105 as our answer. All right, now let's come back to why did I not include the plus c over here? If you do, it's not going to change anything, and here's why. So let's see if I just extend this out a bit and I add our plus c, okay? Well, when I went to evaluate f of 5 and f of 0, gotta make some more room, and that needs to come with it. Okay, let me fix this, plus 0. I would end up with plus c over here because the c would not be affected by a 5. And I would end up with plus c over here. But notice it would be minus c, so it would turn into subtraction. So the c's would end up canceling each other out. This is why I didn't need to include c in the first place. This will be this way for every calculation like this that you do. All right, so we don't need to include c when we are looking for a definite integral. So don't need to include c when dealing with a definite integral. All right, however, when we were looking at the indefinite integral up here, we did need to include the plus c because we were looking at an indefinite integral. Okay? Let's keep going. Let's do it again. We're going to get a lot of practice with it, don't worry. All right, so we have the definite integral from 1 up to e of 5 over t. And this is with respect to t. So we need to go ahead and take this integral. I'm going to do it in one less step here, so I'm not going to look at the indefinite. I'm just going to look at this 5t dt. And I'm going to move the 5 out front, 1 up to e of 1 over t dt. And we'll notice that this is our natural log rule. So we'll get 5 times the natural log of the absolute value of t. And then I don't need to write the plus c because I'm going to go ahead and write evaluated at 1 up to e. All right, so because it's a definite integral, it's going to give us a number, not a family. So we don't need to include the plus c. All right, so then we have 5 times the natural log of the absolute value of e minus 5 times the natural log of the absolute value of 1. This is our f of a, or f of b minus f of a. All right, again, still using our fundamental theorem here. So the natural log of e is 1, and the natural log of 1 is 0. So we end up with 5 minus 0, which is 5. Let's look at part C. All right, so I think we've gotten to the point where we don't need to break down the integrals as much anymore, okay? So I'm going to go ahead and do this calculation. So both of these are just power rules. So we have x cubed. We're going to divide by 3, but we had that 2 there as a constant. So we have 2/3 x cubed minus x squared divided by 2. And then evaluated from -1 to 1. All right. Again, if you need any more details on in-between steps, please shoot me an email. But let's go ahead and plug this in. So we have 2/3 times 1 cubed minus 1 squared over 2 minus 2/3 of -1 cubed minus -1 squared over 2. All right, so this gives us 2/3 minus 1/2 minus, this gives us a negative 2/3, and this is also minus 1/2. All right, let's go ahead and drop the bracket. So we have 2/3 minus 1/2 minus a negative 2/3, so plus 2/3, and then minus a negative 1/2, so plus 1/2. So our 1/2 and our negative 1/2 will cancel each other out, and we will end up with 4/3 as our final answer. All right, and last one for this question, so part D. Let's go ahead and take a look. So this is an exponential rule. All right, so we have e to the 0.5x. We know that we need to divide by whatever constant is in our exponent, so 0.5. But then we can't forget about the 2 that was originally there. And then evaluate that from 0 to 1. And let's go ahead and clean this up. So 2 divided by 1/2, well, that's 4. E to the 0.5x evaluated from 0 to 1. So we have 4 e to the 0.5 times x, which is 1, minus 4e to the 0.5 times 0, which is 0. So anything to the 0 is 1, so we just get minus 4. And then plugging 4 times e to the 1/2 in the calculator gives us 2.59 as our final answer. All right, so example 2, we have to find the total area under y is equal to x squared minus 4 from x is equal to -3 to x is equal to 0. So this is, again, an integral question. So we want the total area, we need an integral, of our function x squared minus 4, cap it off with a dx, from -3 to 0. We were given our bounds, so -3 to 0. All right, so let's go ahead and calculate the antiderivative. So we have x cubed over 3 minus 4x, both just power rule and then constant rule here, evaluated from -3 up to 0. So we want to evaluate at our top bound first. So we have 0 cubed over 3 minus 4 times 0 minus -3 cubed over 3 minus 4 times -3. All right, so everything in our first set of brackets is 0. So we end up with negative everything in our second set of brackets. So -3 cubed is -27 divided by 3. And -4 times -3 is +12. All right, so this becomes +9 minus 12, and we end up with -3 as our final answer. All right, so the total area under the curve is -3, which means we must be below the x-axis for it to be counted negative, right? All right, so example 3, again, we want to find the area, but now between two different functions. Okay, so what do we need in order to find the area between two curves? First, we need to identify the top and bottom curves, and then we need to identify our bounds, right? So in order to find our top and bottom curves, we are going to go ahead and draw a rough sketch. It doesn't need to be perfect, we just need an idea. So x squared minus 9, well, that is an upwards facing parabola, right? And it's going to be centered at -9. So let's say this is -9. So we're going to have a parabola like this. All right, this is x squared minus 9. And then we have x plus 3. So if we just had y is equal to x, it would be a line like this, right? So now we have y is equal to x plus 3, which just gives us an upward shift 3 units. So let's say this is 3, and we're going to draw our line like so. Good enough. And we are then looking for these 2 points. So from our graph, we have determined that our parabola is the bottom function, and the x plus y, our line, is our top function. Okay. Next, we need to determine our bounds. So to do that, we need to set them equal to each other because we need to find where do the two functions intersect. So we have x squared minus 9 equal to x plus 3. We'll go ahead and move everything over to one side. So we have x squared minus x minus 12 is equal to 0. We can factor this into x minus 4, x plus 3 is equal to 0. And so this gives us x is equal to 4 and x is equal to -3. These should be our bounds. All right. So now that we have all this information, in order to find this area between the two curves, we need to take the integral from our bounds. So from -3 up to +4 of our top function, which is our x plus 3, minus our bottom function, which is our x squared minus 9 with respect to x. Okay, so we can clean this up a little bit inside and get that this is the integral from -3 up to 4 of x minus x squared plus 12 dx. All right, and then we can go through and take the integral of each piece. So we have the integral of x is x squared over 2. The integral of x squared is x cubed over 3. And the integral of 12 is going to be 12x. So then all of this needs to be evaluated from -3 up to 4. All right. So we get 4 squared over 2 minus 4 cubed over 3 plus 12 times 4 minus -3 squared over 2 minus -3 cubed over 3 plus 12 times -3. All right, so I plugged all of this into a calculator and got 34.61 minus a -22.5, and so overall our final answer is 57.17. And that's our area between the two curves. All right, so we just found all of this area here. So let's go ahead and look at example 4. This one says we want to find the value of b such that the area under this function between x and b, or between x is equal to 1 and x is equal to b, is equal to 124. All right, so let's try to write down what this question is asking us. So we want the area under a function. Okay, so that's represented by an integral. We know that. We're given the function 3x squared dx between 1 and b, so from 1 up to b. And we want that to be 124. That's what we're looking for. So this question is asking, what is b that makes this statement true? Okay? So what we're going to do is use this fundamental theorem to calculate the antiderivative, and then we're going to set that equal to 124 and see what we get. All right? So our antiderivative is x cubed divided by 3 times the constant that we already had there, which was 3, evaluated from 1 up to b. So this is just x cubed from 1 to b. Okay? So we know that we have to evaluate our top function first, or our top bound first. So we have b cubed minus 1 cubed. All right? So that equals b cubed minus 1. So we've now found our integral, and we want that to be set equal to 124. All right, so we're going to set 124 is equal to b cubed minus 1. So we're trying to find b. We were asked to find the value of b. So we need to solve for b. So we're going to add 1 to both sides, get 125 is equal to b cubed. Take the cubed root of both sides, get b is equal to 5. All right, and we can go ahead and check with a calculator. That this is indeed true. So if we take the integral from 1 up to 5, which is what we just determined the value for b is, of 3x squared dx, and you plug this into your calculator, you will indeed find that the answer is 124. So we found the correct b value. All right. Let's look at example 5. We're told water is leaking out of a tank at a rate of 100 times e to the 0.02 t gallons per hour. How many gallons leak out of the water tank during the first 2 hours? All right, so we're asked what is the total amount of water that has leaked, also known as the total amount of change, which means we need an integral. We're given the rate, so we have 100 e to the 0.02 t dt. And our bounds are going to be values for t during the first 2 hours. So we have our function is in gallons per hour, so t is in hours. So we want to start at t is equal to 0 and go the first 2 hours. So go up to t is equal to 2. All right, so this is going to be an exponential rule, right? So we have e to the 0.02 t. We need to divide by the constant that was up here. So we divide by our 0.02. but then we had the 100 that was already there, so multiplied by the 100, evaluated from 0 to 2. Okay. So we have 100 divided by 0.02 gives us 5,000, all right, 5,000 e to the 0.02 t evaluated from 0 to 2. So we have 5,000 e to the 0.04, that's 2 times our 0.02, minus e to the 0. All right. So we have 5,000 times 1.041 minus 1, which gives us 5,000 times 0.041, which gives us 205 gallons. All right, so 205 gallons leaked out of the water tank during the first 2 hours of the leak. So that is the end of chapter 6.3. Don't forget to take the comprehension quiz, and I'll see you again in the next lecture.